Okay, I want you to imagine a machine, but not one made of silicon and circuits. No, this one's all brass gears and polished levers. A machine that could literally look into the future and tell you the exact rise and fall of the oceans. Well, in this explainer, we're diving into the story of the incredible analog computers that did just that.
This quote from our source material just perfectly sums it up. When you look at these things, they feel impossible, like something out of a steampunk fantasy. But we're not talking about hocus pocus here. This is the magic of pure human ingenuity, of turning abstract math into a physical, ticking, moving reality.
So that's the big question, right? How can you possibly take a force as chaotic and powerful as the ocean tide and model it with clockwork? How can a bunch of gears and wheels know exactly when the waves will be high on some distant beach months from now? It seems impossible.
To really get the genius behind the solution, we first have to appreciate just how massive the problem was to begin with.
Before these machines existed, predicting the tides was just a monumental headache. You'd have teams of people, literal human calculators, working for an entire year just to produce the tide tables for a single port. It was unbelievably slow, incredibly tedious, and if someone made a single mistake, well, it could be disastrous for ships and sailors.
The breakthrough, the real game changer, it didn't come from building better gears. It came from a brilliant mathematical idea that let people see the ocean in a totally new way. The magic, it turns out, had a name: harmonic analysis. So let's go back to 1807. A French mathematician, Joseph Fourier, comes up with this revolutionary idea. He figures out that any complex, repeating wave, it doesn't matter how messy or jagged it looks, is actually just a bunch of simple, smooth sine waves of different sizes and speeds all added together.
And here's a fantastic way to wrap your head around this. Think about music. The complex tide you see at the beach is like a big, complicated musical chord. Harmonic analysis is like having a perfect ear that can listen to that chord and pick out every single individual note that makes it up.
And this shows you exactly what I mean. On the left, you've got the real world, the messy, chaotic tide curve. But on the right, you see its hidden components: a simple, predictable wave from the moon's gravity, another one from the sun's gravity, and others shaped by things like the coastline. Each one is a simple, predictable note. The machine's job was to play all those notes at once, to perfectly recreate the chord of the future tide.
So, the theory was there. The math was figured out. Now it was time for the inventors and engineers to turn these abstract mathematical notes into actual physical motion.
Fourier laid the groundwork, right? Then, in 1873, the brilliant Lord Kelvin builds the very first machine that could physically add these waves together using this incredible system of pulleys and gears. And later, another genius, Albert Michelson, created a device that did the reverse. It could analyze a year's worth of real tide data and figure out the exact settings for each of those simple waves. And those settings, they're called coefficients.
And this is how it all came together in practice. Step 1. A tide gauge sits at a port for a full year, just recording water levels on a paper chart. Then, in Step 2, that chart gets fed into a harmonic analyzer, which spits out the key numbers, those 37 most important notes or coefficients. Finally, an operator sets the dials on the predicting machine to match those numbers, turns the crank, and boom, the machine mechanically draws a perfect graph of the tides for the entire next year.
This whole process really hit its peak with an American-made marvel, a machine so impressive it earned the nickname Old Brass Brains.
Old Brass Brains was just a masterpiece. It was essentially two computers in one. One side had 37 components to calculate the height of the tide, drawing that curve on paper. But the other side, this is where it gets really clever. It was calculating the slope of that curve. By finding the exact moment the slope hit zero, when the curve flattened out, it could pinpoint the precise times of high and low tide. Just brilliant.
And the impact this thing had, it was absolutely staggering. Get this, this machine could do calculations in a single day that would take a human 125 days to finish. It wasn't just a small improvement, it was a complete revolution. It turned a months-long marathon of calculation into an afternoon's work.
So why does this matter? Well, this wasn't just some academic curiosity. The speed and accuracy were vital. It made shipping safer, it helped engineers build ports and bridges, and it even played a critical role in world history. The D-Day landings in Normandy, one of the most complex military operations ever attempted, depended completely on precise tide predictions to have any chance of success.
Now, of course, we all know what came next. Digital computers arrived, and these beautiful brass machines became obsolete. But their spirit, their fundamental logic, is still very much alive today.
And this slide just illustrates that evolution perfectly. Back then, computation was physical. A turning gear was literally a part of the math equation. Today, it's all just algorithms running on silicon chips. But even though the hardware is completely different, the foundational idea, harmonic analysis, is exactly the same.
And that is the crucial takeaway here. Every single time you pull up your phone to check a tide chart, you are seeing the intellectual legacy of Lord Kelvin. The method he pioneered, breaking down the tides into their simple parts, is still the gold standard for predicting the oceans today.
And that leaves us with one final big thought. These machines took abstract math and turned it into a real-life oracle. It really makes you wonder, what other complex problems that feel like magic today, from predicting the stock market to modeling human consciousness, are really just elegant mathematics, waiting for the right machine to come along and bring them to life?